Okay, so for part A, the answer is obvious. As x goes to infinity, the limit is 0 because the degree of the denominator is greater. By the way, we could also talk about the limit as x goes to negative infinity, which would also be 0 because the degree of the denominator is greater, so that's just, positive and negative 0 don't even matter really, so when the answer is 0, it doesn't matter if you go to negative infinity or positive infinity. Now we could talk about this, and the answer is the same. Here, the answer is 1. Now, you could do this by just canceling these two numbers and writing this function as 1, because it is equal to 1 for all values other than x. Or you could say that they have same degree, and therefore the answer is the ratio of leading coefficients, so it's 1 over 1. However you answer that one is fine. This is equivalent to just x, so as x goes to infinity, it goes to infinity. As x goes to negative infinity, this goes to negative infinity. Okay. This one is really very much the same. The degree of the numerator is greater. So as x goes to infinity, this goes to infinity. As x goes to negative infinity, now here we have something slightly interesting. This will always stay positive. The only thing that really matters is the leading term, and this will be a positive leading term even as x goes to negative infinity. But this will be negative. So you will be dividing a positive number by a negative number. So actually, as x goes to negative infinity, this goes to negative infinity. Okay. Here we have the numerator's degree is basically 2. I could multiply it out, or I could just see it right away. Here, the denominator's degree is 3. So the limit at both positive and negative infinity is 0. Here, it takes a little bit of work. So this is where I do what I call rooting the square. And I say that this is equal to SQRT. So in the top, I don't do anything at all. But I want to combine that with the bottom. But how do I do it when it doesn't have a square root? I give it a square root, but if I just gave it a square root, that would change the thing, and that's not allowed, right? That would be answering some other question if I just took its square root. So I have to compensate, and the way I compensate is by squaring that value inside. So this really is the same thing as x. And now that they both have a square root on them, I can combine them. So this is then equal to square root of, now I'd have x squared over x squared is 1. I would have 1 plus 1 over x squared. And now I can say what happens as x goes to infinity. As x goes to infinity, this term just disappears. It turns into 0. And I'm just left with square root 1, which is equal to 1. So there's the solution.